Welcome back. We have a pretty interesting topic today. Equations reducible to quadratic form. Learning to do this will help you look at strange equations and be able to figure out what to do with them. Now, not all equations are reducible to quadratic form, but many of them are, and we'll show you how to recognize the ones that are, and then once you have one that is reducible, what you can do with that. Now remember that the next slide, when I have this 5-minute slide here, this is something you can skip over if you feel pretty confident. What it does, it kind of reviews what we've had in a previous lesson and sets you up for the coming one. Find the solution to this quadratic equation. How many solutions do we expect to find? This is the highest power, defines the power of the equation. This is a second power. We expect to find 2 solutions. Anytime we have a quadratic, we can approach it as something we may be able to factor into 2 linear binomials. Excuse me. If we've got 2x squared, we know the only way that would factor evenly would be 2x times x to give us 2x squared. 1, now that's pretty simple. That's got to be 1 times 1. And remember, we get our sign from the middle term, which is positive. And because this is also positive, we know they both have to be positive. The only thing left for us to check is the middle term. Does it work? We go to the outside. 2x times 1 is 2x. 1 times x is 1x. 2x plus 1x is a positive 3x. That checks. So we're going to do our mini equations. 2x plus 1 equals 0 for this factor, and x plus 1 equals 0 for the other one. So this would be 2x equals negative 1, or x equals negative 1/2. This one will be x equals negative 1. Okay, so let's see if that's what I have behind the hidden behind this door here. Yes. X equals negative 1/2, x equals negative 1. All right, let's try another one. Find the sum of a quadratic equation given that the sum of the roots is 7. Now what was that? The sum of the roots, so we had one solution plus the other solution equals 7. Well, it doesn't look much like a 7. I'm going to be careful. What else did we say about the sum of the roots? The sum of the roots, those 2 solutions added together, equaled negative b over a. Remember that? And then the product of the roots, which would be those 2 solutions multiplied together, equals 1. And we recognized that the product of the roots was also equal to c, a positive, c over a. So this means we could write our equation as x minus minus b over a x plus c over a equals 0. So I'm going to substitute in, first of all, the sum of the roots, which is 7. So it's 7x. And then plus the product of the roots, which is 1. Okay, let's see if that bears out when I look behind this door here. Oh, you probably were telling me, right? What is the matter with me? This is x squared, of course, x squared. Well, you'll pardon me if I make my own occasional foolish error, huh? Now we're going to look at this last one. Find a quadratic equation whose solutions are 1/7 and 1/4. Well, what I know is that the sum of solutions is going to be equal to negative b over a. True? And in this case, to add these two together, I have to find a common denominator, which would be 28. So I'm going to multiply this by 4 over 4 and get 4. And this I'm going to multiply by 7 over 7. So I get 11 over 28 is equal to negative b over a. And then the two solutions multiplied together will be 1 over 28. So I'm going to use this equation right here, the quadratic equation. I'll say x, watch me now, x squared, proud of me, minus this, which is 11. Oh, wait! What am I doing? Making it into a pie. Oops. Minus 11, 28 times an x, right? That's minus whatever my negative b over a was. And then plus the product of the two solutions, 1 over 28. And of course that's all equal to 0. Now there is a problem here because I've got 28 in the denominator. So if I multiply everything here by 28, I'll get 28 x squared. Now multiplying this by 28, the 28 and the 28 in the denominator cancel out, which is exactly what I wanted to do. And I'll do the same thing for this term. And then I'll multiply my 0 by 28. That's an easy multiplication. So this is what I find for the quadratic equation. And we'll see what's hidden. We'll see what's hidden. Oh, what in the world is going on here? Sorry about that. Maybe I'll stop looking at what's hidden. It just seems to be too difficult. Ah, but you know, I found I can make so many stupid errors myself. It's better if I check with what I put in there when I originally made the problems. Okay, so this looks good. We're 10 minutes in, and those of you that didn't need this review, you saved yourself 10 minutes when you skipped by it. But look at all the nice instruction that you missed. Okay, what number squared will equal, what number squared will equal x to the 6th? So let's call this u. The number we're looking for is u. How would I find out what u is? That's right. I take the square root of both sides. So I'd have u equals, and it actually would be plus or minus, wouldn't it? Let's test that. If I have a positive x cubed and I square it, remember, power of a power, we multiply the exponents. So that works. And what if I had negative x cubed squared? Well, when I multiply these two negatives together, they become positive. Check. What number squared will equal this? Well, we're going to try the same technique again. We'll say some number, which we do not know, squared equals the square root of x. Now, what would we do to figure out what this is? We've got to solve for u. How do we do that? Well, we're going to have to take the square root of both sides. Now, oh, that looks wicked awful. I don't like that. Well, this side looks fine. No problem with that. But over here, what do I end up with? Let's rewrite this. And I should be saying plus or minus, shouldn't I? And I'm going to write it in rational exponents. I think it'll be easier. So instead of saying a radical square root of x, I'm going to say x raised to the 1/2 power. And then when I apply another square root, I'll do it this way. You see how that really is so much easier? That's why I love rational exponents. Power of a power, when I multiply 1/2 times 1/2, what do I get? X to the 1/4. Let's test it. Oh, and I did say plus or minus, didn't I? So if I have x to the 1/4 and I square it, I get x to the 2/4, which is equal to x to the 1/2, which indeed is equal to the square root of x. If I have negative x to the 1/4 and I square it, this coefficient of -1, when I multiply it times itself, becomes a positive, and I end up in the very same place. Okay, so let's try this one. What number squared, what number squared will equal x to the 1/3? How are we going to solve this one? We're going to multiply everything. Well, no, we're not. We're going to raise to the power of 3. No! Wait, what am I thinking? X squared. You know what I was doing? I was trying to solve for x. That's not what we want to do. I want to remember that right now I'm solving for u. How do I solve for u? I'm going to take the square root plus or minus the square root of this, which will be equal to plus or minus. Let's write it with rational exponents. This was already in it, rational exponents. And when I take the square root of that, it's equal to plus or minus x to the 1/6. Let's try it. If I have x to the 1/6 and I square it, it will equal x to the 2/6, which will equal x to the 1/3. I'm not going to go through and do the negative again because I think that's pretty clear. Okay, so let's try using what I promised to you, reducing equations to the quadratic form. Now here is something which is not in the quadratic form, is it? Quadratic form is when your highest power is squared. However, I would like to transform this into quadratic, and I believe that I can. My a is 1. My b is -9. And my c is a +8. Instead of saying x, I'm going to substitute u. I'm going to define u as, okay, what number squared will equal x to the 4th? Whoops. What number squared will equal x to the 4th? Go ahead and do it. Yes? That's right. X squared. Did we go through one just like that? Well, pretty close, if not exact. So we're going to say our u is going to be equal to x squared, and we're going to rewrite this as u squared, and notice our leading coefficient a is 1, minus 9. Instead of writing x squared, we're going to write u, and that's to the first power, plus 8. Now, one thing I want to point out to you here, which is usually helpful, if it's going to be reducible to the quadratic form, whatever you find as your middle term, that's going to be what your u is equal to. Excuse me. Excuse me. All right. The other thing you should notice, if it is reducible to the quadratic form, the power on your leading term, your highest power term, is going to be double the power of your middle one, which is true here, isn't it? Okay, so let's go ahead and solve this. So that's what we just did. We realized that instead of using x squared, we could use u. And now, let's just get rid of this thing. This isn't that hard to solve now, is it? We're just going to say, we believe we can get two linear binomial factors out of this. Of course, the first term has to be u, and this, well, this could be many things, couldn't it? Well, we're looking for two factors of 8 that when we multiply them together give us a positive 8, of course, and when we add them together give us a negative 9. Obviously, they're both going to have to be negative. And what would work? 8 and 1. That'll give us a negative 8u. This will give us a negative 1u. We're in business. So our u is equal to 8. If we do the little mini equation, you come out with u is equal to 8, and the other one will come out with u is equal to 1. But were we interested in finding out what u was? No, that really was just a help to us along the way. What we want to know is what x is equal to. We defined u as being the same as x squared, so let's put that in now. X squared equals 8. X squared equals 1. X is equal to plus or minus the square root of 8. Excuse me. X is equal to plus or minus the square root of 1, which is 1. Now let's see what we can do with this. We can make this a little prettier, can't we? Plus or minus the square root of 4 times the square root of 2 plus or minus 2 square roots of 2. I hope you see just how we got there. Now, how many solutions did I get to this problem? Look at that. A plus and a minus, that's 2. A plus and a minus, that's 2 more. What did we expect to get? That's right. We expected to get 4 because that was the highest power. How interesting. Okay, let's try it again. On this one, well, first of all, let's notice that we've got 6, which is double what we have here. So this looks like it might be reducible. And right where our middle term is, that's what our u is going to be. U equals x to the 3rd power. Let's try substituting in u for our x's. If u is equal to x to the 3rd power, then u squared must be equal to x to the 6th power. Agreed? So for x to the 6th power, we're going to put in u squared plus 6u, right? We're using u's now. I'm not going to use x's because if we use the u's, we can get down to the form we're so familiar with, the quadratic form. Plus 9 equals 0. Okay, let's try factoring this. We know this is going to be u and this is going to be u. I need 2 factors of positive 9, which when I add them together will give me 6. I think that's right. 3 times 3, of course. Isn't that nice? So, I've got ready equations. U plus 3 equals 0, and U plus 3 equals 0. What do we call this? Do you remember this? These are redundant, which is nice. We only have to solve one, but we know that it represents two different solutions for this. So we've got U is equal to a negative 3. We also know that U is equal to x to the third power, and really what we want to know is what x is. X to the third power is equal to negative 3. So what are we going to do to find out what x is? That's right, we're going to say x to the, wait a second, x to the third power, and we're going to take the cube root of that. And of course over here, what we do to one side of the equation, we do to the other. Take the cube root of this. So we end up with x equals the cube root of negative, let me write the cube, of negative 3. We also know that that was redundant. Okay. Solve for, solve for x. Yikes. Now, this one is a little peculiar, I think, unless we realize that this is x to the first power. I know I'm writing it in a strange way, but you'll perhaps understand in just a moment why I'm doing that. I'm converting over to rational exponents because, I don't know, somehow I think they're easier to understand. We know that if it's reducible to quadratic form, that the first term has to have a power that's twice as large as your second term. And that is the case, isn't it? So we can say U equals x to the 1/2 power, or of course, U is equal to the square root, positive square root of x. Okay, so U, this will be U squared, right? Minus 6U plus 8 equals 0. Can we factor this? This piece is easy enough, U and U. We need two factors of positive 8 that when we add them together give us a negative 6. Those will do it, won't they? So we end up with our U being equal to 2, or our U being equal to 4. We weren't interested in finding U, we are interested in finding x. U is equal to the square root of x. So we can rewrite these both with x, and now we can solve for x. If it's a square root, how do we get to x? We square both sides. X is equal to 4, or x is equal to 16. All right. This one, this one really looks strange, but you will notice that the middle term here has an exponent of 1 on the unknown, and right now I'm calling the unknown this whole this whole binomial. And this has a power twice as large. So I could define my u as 2x minus 1. This would then read u squared minus 4u plus 3 equals 0. I factor. This has to be a u, this has to be a u. Two factors of positive 3 that when I add them together give me negative 4. Good. Okay, so I've got u is either equal to 1 or u is equal to 3. I know that u is equal to 2x minus 1 and 2x minus 1. Just a moment here while I give us a little more space. Move this. Oh! Alright, it's a little more complicated. Alright, I can handle it. Whoops. Draw. Come on. I hate to waste your time like this. Okay, ungroup. Wow. I just want to get this down here out of the way so we have a little more room to work. Alright, so I'm going to add 1 to both sides. I get 2x equals 2. X, therefore, must be 1. And this one I add 1 to both sides. 2x equals 4. X equals 2. And we'll do this last one, which is kind of the weirdest one we've seen, isn't it? But notice that the exponent here is twice as large as the exponent of your middle term. So this is reducible to quadratic form, and we've got a u equal to x to the 1/3. Let me rewrite this with u's. So here I'll have u squared minus 3u plus 2 equals 0. We factor that. I get u, and over here it's got to be a 2 and a 1. That's the only thing that it could be. And they both got to be negative. So we've got either u is equal to 2 or u is equal to 1. I know that u is equivalent to x to the 1/3 so I rewrite these with x to the 1/3, and now I solve for x. How do I do that? I cube both sides. I end up with x equals 8, x equals 1. How do you like that? That's the end of this lesson.